Hello friends, today let's solve the shortest path with alternating colors. Consider a directed graph with no nodes labeled 0, 1, n2, n-1. In this graph, each edge is either red or blue, and there could be self-edges or parallel edges. Each ij in red edges denotes a red directed edge from node I to node j. Similarly, each ij in blue edges denotes a blue directed edge from node I to node j. Return an array answer of length n, where each answer x is the length of the shortest path from node 0 to node x, such that the edge colors alternate along the path, or -1 if such a path doesn't exist. So let's think how to solve this problem. You see, actually there is a great hint, that is, this actually asks us to find the shortest path, and if you see carefully, actually this is unweighted graph. So usually when we try to find the shortest path in an unweighted graph, we will use breadth search. But this problem seems differently because it asks us to weight the edge alternate along the path, which means we choose one blue, then red, then blue, then red. So how to solve that problem? I think first thing we need to try to find a better way to represent the graph. I think the adjacency matrix is a good way, because if there is a red edge from node I to node j, we mark it as 1. The same if there is a blue edge from node I to node j, we mark it as -1. But as they may have the parallel edges, that means they may have some exact same edge in red edges and in the blue edges. So we mark it as 0, which means it has two edges in these two parts. So then we represent the graph. We can just do a normal breadth search, except because we do not know the first node go red or go blue, so we need to offer the node 0 twice. One choose red edge, the other choose the blue edge. This is another thing we need to notice. And also we need to avoid the weight the same node and the same edge twice. So we need a hash set to mark the same node and the same edge. So we do not just mark the node or the edge, because we may weight it twice, but all we need to mark is the node and the edge. So let's see what do I mean. First, we need to use a adjacency matrix to mark the edge. We use a 2D array. The size will be n times n. If it only have a red edge from I to j, we mark it 1. If it only have a blue edge from I to j, we mark it -1. If it have both edges, we mark it 0. Otherwise, we just mark it as an alternative value. I use -n. Okay, then we use a q to do the BFS. Because we're not sure which edge the first node will take, so we offer this two array into the queue. Actually, the queue use the int array. The first dimension is the node, and the second dimension represents the color. So we first will offer the 0, 1. That means it takes the red edge. Then we also offer the 0, -1. That means the blue edge. Then we just do a typical breadth search. We get the size of the queue, because in the queue at the same time, actually we get the size of queue because all the nodes in the in that time, at that time we'll have the same length to the node 0. That's the reason we get the size of the queue. Then we iterate all the nodes in the queue. We get the cur, and the node will be cur 0, and the color will be cur 1. The reason that I use the 1 and negative 1 because I can easily get the opposite color. That means if current color is red is 1, right? So we need to find the opposite color, which will be the negative 1. So we just get the negative color to get its opposite color. So then we just iterate all the nodes if they have the parse from the current node to the I. Why I write the equal to 0? Because you should notice that if it's 0, that means it has 2 colors. So that should always works. If we haven't visited this I before, we first mark the current node and the current color as visited. Then I offer the current node and the color into the queue. At the same time, update the result I. The reason is that because it's a breadth-first search, if we visit the same node, afterwards it will have the longer path because we can visit it before. That means we can have a shortest path, have the short path. So that's the whole reason. And finally, we visit the result array again. If the integer max value, we just update the value to negative 1. That means there is no path from node 0 to that node. Let's see this example. If the n is 3 and this is the red edges, 0, 1, 0, 2, and this is blue edges, there is 1, 0. We get the n times n matrix. Then we mark the 0, 1 to the 1, and mark 0, 2 to 1. Also, we mark the 1, 0 to negative 1. All the other values will be negative 3. Then we pour the first, offer the first 0, 1, and 0, negative 1 to the queue. Then we do the breadth-first search. We first pull this value from the queue. A node will be 0, color will be 1, the opposite color will be negative 1. We try to find the negative 1 and the 0. Let's see. There is no node we can visit from this node, so we cannot find. Then we keep a pull from the queue. Then again, node 0, and color will be negative 1. The opposite color will be 1. So we try to find the 1 and 0. Then we find these two nodes is 1, 2, right? So we offer 1, 1, and 2, 1 into the queue. At the same time, after the result 1 to the 1, because the current length is 1. And then we keep a pull from this queue. And the node is 1, color is 1, the opposite color is negative 1. And we try to find negative 1 and 0 in this matrix. The row is 1. The column is 1. Which we needed to find the negative 1. Yeah, we find this value. But you know that the result 0 will always be 0, so we cannot update this value. But just keep do this breadth search. And then we pull this 2, 1 from the queue. The node will be 2, color will be 1. We try to find negative 1 and 0. We cannot find, but we can update the result 2 to the 1 because the current length is 1. So at the last we get result array 0, 1, 1. So I hope you can understand this algorithm. Now let's write the code. The first thing is to build a graph, right? So we first new 2D array. There will be graph new n. Then we call a function named build graph g, and there will be n the red edges, and there will be blue edges. Okay, let's first implement this build graph. We write this g, and there will be n, and there will be red edges. that will be the blue edges. Okay. Then first thing, we need to initialize all the value in the graph to the negative n. But actually, you can initialize to other value. I++. Erase, fill this gi to the negative n. Then for every edge, rate edge, first from the node E0 and to the node E1, we mark it G from 2 equal to 1. That means a rate edge. And for every edge in the blue edges, in from will be E0, 2 will be E1. And if we already see a rate edge, if equal to 1, that means there is already a rate edge. We mark it to 0, which means it have 2 edges. Otherwise, we mark it to the negative 1. Okay, so we build this graph. Then we need to do the buffer search into array q new linked list. Then we offer the new int 0, 1. That makes it pick a red edge and offer new int 0, negative 1. We also name length. At first is 0, right? Also the result array. The size will be n. And at first we initialize to the integer max value. And the result 0 will be 0 because you know that. Then I also need a set to mark the nodes and the edge we seen before. VT, the new hash set. Okay, while the queue is not empty, we first get the size of the queue. There will be queue.size. And the length plus because in here the length to that node will at least be 1, right? So it first is 0, so here it should be 1. And for int I equal to 0, I less than size, I++. We pull from the queue. Curl will be queue pull. We get the node. The node will be the first dimension. The color will be the second dimension. And we want to find the opposite color. Opposite color will be negative color. Okay, then we just iterate the node because the data is small. So for int j equal to 1, j less than nj++. If g node j equal to the opposite color, or g node j equal to 0, because 0 it means have both edges if equal to 0. If visited, we try to visit that at the j. We convert that to the string at the opposite color. If return false, which means we visited before, so we just continue. Otherwise, we offer that j and the opposite color into the queue. At the same time, update the result to the minimum result j and the length. Okay, finally check whether if some value equal to the integer max value. If this, that means we have no way to visit that node. We get value to the negative 1. Finally, we return result. Okay, thank you for watching. See you next time.